Friends, today in this video lecture we'll see or we'll discuss the sag in the overhead transmission line and how the sag is calculated. Okay, let us see the definition of sag. Sag in the overhead transmission line, it refers to the difference in levels between the point of support and the lowest point on the conductor, like this. This is the point of support and this is the lowest point on the conductor. This, let us say AB or is a conductor, okay, and we have a supports at point A and B, okay, and sag is the difference between the levels of point of support and the lowest point on the conductor. Okay, this is called as a sag. Why sag is important in the conductor in the transmission line? While erecting an overhead transmission line, it should be taken care that conductors are under safe tension. If the conductors are too much stressed, like this, let us say this is one support and this is one support, okay, so this is your transmission line. If I in a bid to save the conductor, if I stretch this, what will happen? There will be a high tension in this conductor. There will be too much of tension. So what will happen? The tension in the conductor may reach unsafe value and the conductor may break. Therefore, we have to reduce the tension in the conductor. How we reduce? Lose it like this. So if you let loose this conductor, of course the tension will be decreased, but at what cost? There will be a sag or conductor material will increase, right? But tension is less. Okay, so there is a trade-off between this sag and tension. Okay. Therefore, in order to have a safe tension in the conductor, they are not fully stretched. Rather, a sufficient dip or sag is provided. The sag in the transmission line is so as to maintain a tension in the conductor within safe limits, safe value. In case of, suppose there is a seasonal variation, like fall of ice or a blow of wind. This will not affect the transmission line. If the tension is more, because of this wind and ice, the tension will increase on the transmission line and conductor may break. So we need to understand, we need to notice some 3 points here. One is the tension at any point on the conductor acts tangentially. Therefore, the tension at the lowest point on the conductor is horizontal. This is the tension. I'll show you this. See, this is the tension, and this is at any point on the conductor. This tension acts horizontally. This tension acts horizontally at any point. At any point it acts horizontally. Whether it may be this point or it may be this point or this point, it acts horizontally, or the tension at any point on the conductor acts tangentially, like if at all I take this point, okay, if this is the point, then it will act tangentially like this. If I take this point, then it will act tangentially. Okay, so therefore the tension at lowest point on this conductor acts horizontally. Okay, the horizontal component of the tension at any point on the conductor is constant. This horizontal component of the tension at any point on this conductor is constant. The tension at the supports, the supporting points, the tension at this point of support is nearly equal to the horizontal component of the tension. Okay, these are the 3 points you must note. One is the tension at any point on the conductor acts tangentially. Other one is the horizontal component of the tension at any point is constant, and the tension at the support points is nearly equal. Okay. Let us calculate the tension now. The tension on a suspended conductor is governed by 3 factors. One is weight of the conductor, another one is effect of wind, ice loading, and temperature variations. Generally, the conductor tension is kept less than 50% of its ultimate tensile strength. Okay, what is this ultimate tensile strength? This is the maximum strength what a conductor can withstand. So working tension, conductor tension, that is the working tension. The working tension is always 50% of its maximum withstanding ultimate tensile strength. Okay, for example, if the conductor can withstand a maximum weight of 200 kg, 2000 kg, then we can put only up to 1000 kg on the conductor, not more than that. That is, generally we give a factor of safety of 2. Okay, the value of sag is calculated for 2 different scenarios. One is supports are at equal levels and supports are at unequal levels. Let us calculate the first one, that is supports are at equal level. When the supports are at equal level, let us consider this. Okay, let us consider an overhead transmission line which is suspended between points A and B. That is, we have supports at point A and point B. O is the lowest point on the conductor. The lowest point O is between support A and support B. What does it mean? It means that point O bisects the span equally. That is, if L is the length of the span, then OA is L by 2 and OB is equal to L by 2. Okay. Now, let us see this. Let L is a horizontal distance between the 2 towers. This is L. L is the horizontal distance between the 2 towers, that is span. W is the weight of the conductor per unit length. T is the tension in the conductor. Let take any point P on the conductor. Let us take any point P on the conductor. Assuming O as a origin like this, I have taken P, any point on the conductor, and O is origin like this. Okay, OP is our now new line. So the coordinates of P is XY. Coordinates of P will be Let us assume that the curvature is so small that the curved length is equal to the horizontal projection. This is curved length, okay? OP is a curved length. This is so small that the length OP is equal to X, okay? So there are two forces which are acting on this portion of OP. One is the conductor weight, okay? Weight W into X, okay, which is acting at a distance x by 2 from origin O. Another one is the tension, which is T, acting at point O, okay. Now equating the moments of the two forces. What are the two forces? One is weight of the conductor, another one is a tension of the conductor, right? Equating the two forces about the point O, what will get? T into Y is equal to, what is the weight? W into X, okay, W into X, that is Y coordinate. And what is T? It is X by 2. So W into X into X by 2, or Y is equal to W X square by 2T. So now Y is W X square by 2T. So this Y is what? It is the sag of portion OP. Okay, this Y represents the sag of portion OP. If I want to calculate the sag of this whole conductor, then this I will take, I will take point B or point A, sag at point A or sag at point B. Therefore, if I take sag at point A or point B, then X becomes equal to what? L by 2. So substitute this in this equation. What we will get is S is equal to W into L by 2 square by 2T, right? So S in place of Y we put S, and in place of X we put L by 2. So what we will get is S is equal to W into L by 2 square by 2T. After simplification, what we will get is S is equal to W L square by 8T. This is the equation for sag. This is the equation for sag when the two towers are at the same level from the ground. Okay, so this is the first case when the supports are at same level. Okay, next class I will take up when the supports are at unequal level. Okay.